Hey YouTube, welcome back to another episode in my LeetCode series. In this one, I'm going to be going through problem number 27, which is remove element. So, given an integer array nums and an integer val, remove all occurrences of val in nums in place. The order of the elements may be changed, then return the number of elements in nums which are not equal to val. Consider the number of elements in nums which are not equal to val to be k. To get accepted, you need to do the following things. Change the array nums such that the first k elements of nums contain the elements which are not equal to val. The remaining elements of nums are not important, as well as the size of nums. Return k. So basically, what is it saying here? It's going to give you an array, let's say something like 1, 2, 2, 3, 4, 5, and 6. And let's say val is equal to 2, we would have to return something like 1, 3, 4, 5, and 6. And we don't have to return this exactly. We have to just make sure the first k elements are in order. And then we could have something like 2 and 2 back here, for example. As long as you return k and you specify which elements are in order, you should be fine. There's two solutions to this problem, both run at O of n time complexity, and I'll take you through the more obvious one first. So what we're going to do is we're going to say, so we can start this off with a simple for loop. So I could say for var I equals 0, I is less than nums dot length, I plus plus. So we loop through the array, and then for each element in the array which is equal to val, we can simply splice our array. So nums dot splice at index I, and we're cutting out 1, and this should work, right? Well, it's not going to work. We only passed 85 out of our 113 test cases, and this is a common pitfall where some of you might get stuck. You might be wondering, why doesn't this work? We're doing exactly what it asks us to. We're looping through the array, we're finding the value, and then we're cutting it out. Well, when we're removing a value from the index or cutting it out, whatever you want to call it, splicing it, we have to remember that once we splice this, the index actually changes. So what we need to do is we remove this I++ here, and then we add it down here. And the reason for that is that once you take an element out of the array becomes smaller, so the index actually points to another value. So we don't want to update the index twice. Now if I submit, oh, and this should be an else statement, I'm sorry. This should be inside an else. So now, the reason we need an else statement is because it's going to run I++ either way. I forgot about that. If I press submit, now you'll see we got the correct solution, but we're only beating 44.65% users with JavaScript. So how can we make this faster? Well, I'm going to delete this code right here, and I'm going to show you a new approach. So let's say I had the following array. Let's say I had 0, 1, 2, 2, 3, 0, 4, and 2. And the value we want to remove is 2. What I'm going to do is I'm going to set up 2 pointers. One of these pointers is going to be k, and another of these pointers is going to be called I. So basically how this works is that we have 2 pointers, k and I. What I is going to do is it's going to increment through the array. What k is going to do is it's going to trail slowly behind and change all the values which equal to val to a different value in our array so it can be organized. And I'll show you how we do that. We do that by doing a simple check. Every time that the value at I is not equal to val, we're going to increment k, and we're going to set the value that was at k to the value at I, and then we're going to increment k. And I'll show you what this does right now. So let me show you how these pointers move. So first we're going to do a check to see if I is equal to the val, which it's not. So we're going to set the value at k equal to I. We're going to increment I, and we're going to increment k. Next, we're going to check, does the value at I equal val? It doesn't, so we're going to set the value at k to be the value at I. At this point, it all stays the same. Then we increment k, and we increment I. Next, is the value at I equal to val? No, it doesn't, so we increment I. So we set the value of k to the value at I, and we increment k. Then we increment I. Next, is the value at I equal to val? Yes, it is. So in this case, we just skip forward. Now, is the value at I equal to val? It's not. So what do? We set the value at I equal to the value at k, which is 3. Then we increment k, and we increment I. Next, is the value at I equal to val? It's not. So we set the value at I equal to the value at k, which is 0. Then we move k forward. Now we increment I. Again, we do the check. 4 is not equal to 2. So we set the value at I equal to the value at k, which is 4. We increment k, and we increment I. Finish with our loop. And now the first k elements, you'll see, do not contain any number 2. And we'll return k, because k is going to be 0, 1, 2, 3, 4, 5, 6. K is going to be 6. So the compiler knows to check only the first 6 elements. So I hope that made sense. Let me show you how we're going to code this. So basically what we're going to do is we're going to set a variable, let k equals 0. Now I'm going to write our for loop. So this is going to be our first iteration. And now I'll say if nums at I is not equal to val, we'll say nums at k is equal to nums at I, and we'll increment k. And then this should be good to go. Alright, so what I forgot to do is I forgot to return k. Now if I submit, you'll see that we beat 93.12% of users with JavaScript. So let's go through the time and space complexity of this. The time complexity is going to be O of n, because we're looping through the length of the array only once. And the space complexity is going to be O of 1, because we just defined a simple k variable. But anyways, guys, that's going to wrap up today's video. Make sure to like and subscribe if you enjoyed. You don't have to, but it helps out the channel. And thanks, guys. Have a good day.